Yes, class, good morning. My dear students, as you know, nowadays COVID-19 problem is going on a lot of. How do we all protect ourselves from it so that we can all be safe? First, wear mask properly. Second, stay at least 6 feet from others. Wash your hand frequently. Don't touch your face, don't shake hands, and don't share food and waters with others. The dear student, in this way we can protect ourselves and other also. Yes, student, today we'll discuss here a new topic, limits and derivatives. So today we'll discuss here limits and a new topic, limits and derivative. Limits and derivative. Yes, student. So what is the limits and what is the derivative? Both are the different things here. First we'll discuss about the limit, then we'll discuss the derivative. The first thing, suppose any function here given fx equal to 1. What value of the function? Value of the function fx equal to 1 when x less than equal to 0. Means when value of the x equal 0 or less than, then value of the function is 1, and when value of the function is 2 when x greater than 0. The two conditions here. The first condition here given when value of the x less than 0 or equal 0, so then value of this function is 1, and this is the domain part, this is the codomain part. So this is the domain part or this is the codomain part. Next thing, to when value greater than is when value of the x greater than 0, then value of the function is 2. So then discuss about the first we'll draw the diagram here to how it possible. Suppose in this way. Okay, this is the x-axis, or this is the y dash, and this will be the y. Suppose this value is the codomain value. Codomain value always represent in the y-axis, or this value represent the domain value, or domain always represent in the x-axis. The first of things, what is your domain? Domain is 0. Suppose you have 1 point here, and this is the 2 point. The first of all, we will check this. The value of the function is y equal to fx. This function y equal to means this is the domain part. Y is called the codomain part. Y is called the codomain part, or codomain part is represented by the fx. Y means fx. First of all, this value represent the equal sign. Suppose you are removing the equal sign, then situation will be different. But using your equal sign, the situation will be different. Or this is the left side, less than 0. Or according to the number line here, according to the number as 0 or -1 +1. So this in this direction is the LHL, left hand limit. Or in this direction is the RHL. Suppose you are using the point on the 0, you are as a function value of the x equal to a. Sorry, 0, value of the x equal to here 0, then how it possible? This right side of the 0, this is the RHL, left side of the 0, this is the LHL. Same thing any other number. Suppose you are taking here +2, so every time right side value is called the RHL, left side value is called the LHL. That means when you using the right side portion, then you are using the RHL, or when you using the left side or any value, then it is the LHL, left hand limit. The same things here. It means you are moving here x less than 0 in this direction, but here 0 including here, then you will be here 0 including means you will make a solid part here. What is the coordinate of this? 0, 1, and this portion is called the LHL, left hand limit. At second part here not equal sign, here not is the equal sign, here only here value of the x 0, or on the y-axis value of the x is equal to 0. On the y-axis the value of x is 0. value of on the y-axis value of the x is 0, or on the x-axis value of the x-axis value of the y is 0. This is the property of the coordinates. The second part here include here equal sign using, then you are making here the solid form, but here is not equal sign, then you will make hollow form, and this will be the right hand limit. That means right hand limit. Why is right hand limit? Because the x value of the x more than 0. Value of the x is more than 0. That means right hand. This is the coordinate of this point here 0 2. Coordinate of this point here 0 2. Value of the x here 0, but value of the y here 2. Same thing, value of the x here 0, but value of the y here 1. But different things here. This exact on the y-axis, but here not exact on the y-axis. This is the here hollow portion. This is not solid portion. This is a hollow portion. Here means the 0 is not including more than 0. Means the how to represent of this. So when you represent this left hand limit, when you represent the left hand limit, you will write the limit x tend to 0 minus. Or when you represent the right hand limit, the RHL, the limit x tend to 0 something plus. So 0 something plus means 0 plus, yeah. Otherwise you can write here the limit x tend to 2 minus, means this minus sign represent the left hand limit. Same things here, the limit x tend to 2 plus, this sign plus sign represent the RHL, right hand limit. So in a particular value of the 2 here, suppose function find the value of the function at x equal to 2, then you will be first find the LHL. X equal to means x 2 minus 2 bar means left hand limit, और x plus means हो जाएगा 2 plus means हो जाएगा right hand limit. So suppose you are finding the value of exact of the function at x equal to 2, so first of all you find the LHL and RHL. So both the function here is equal, then you can say the function is continuous, otherwise not continuous. After that you will discuss here what is the left hand limit and what is the right hand limit. This means limit having the two portion, left hand limit and right hand limits. Left hand limits and right hand limits. So we can say that limit fx. What do you mean here? Limit x tend to, suppose x tend to a part here. So then you can write minus sign here. X tend to left hand limit is the expected value of f at x equal to 8, given that the value of the near of the x left side. What is the nearest value of the left side? Same things here, and limit, you can say x tend to any integer here plus sign. This is the fx. A is the any integer. A is belonging to the any real number. A belongs to the any real number here. So then fx is expected the f x tend to a given value of the f near to the right of a, right side of the a. This is the right side of the a, and this one is the left side of the a. The value is called the right hand limit, or this value is called the left hand limit of fx. So in this way you can say that the limit fx x tend to a denoted by limit x tend to a fx. So then you can limit here represent the limit x tend to a fx. Suppose you are finding this portion, so you will check this portion and this portion also, then you can solve question. Yes, the next things here, algebra of limits. So the next point we will discuss here, okay, what is the effect of the algebra of the limits. Algebra of limit. Then discuss in this point. Suppose f and g be two function. Suppose they are given कि f and g are two functions such that both limit x tend to a fx and second limit x tend to a gx in this form. This will be exist of this. But then suppose two functions are given in this form. So what is the operation of the two functions here? The first condition here, when limit of sum of two function. First condition is limit of sum of two function. So then how to write it? Limit x tend to a fx plus gx equal to, then you can write here limit x tend to a fx. Suppose question in this form, you can do easily separate here, plus limit x tend to a gx. Suppose two functions given in this form, in the sum of the two functions you can do separate and to solve and using the limits. Second condition, same things here. Suppose two function here given. Next things here, the second condition here, suppose difference of two function here, that means in this form the limit x tend to a fx minus gx, then you can use the separate form x tend to a fx minus limit x tend to a gx. You can use this one. Third condition, third operation of the function here, when limits of product of two function, the limit of product of the two function here, limit x tend to a here gx into fx equal to, you can do separate this, the limit x tend to a gx dot limit x tend to a, then you can write this limit and fx. Fourth operation here, when limit in the division form, limit the quotient and two function is quotient, then you can separate this limit x tend to a here fx upon gx. So how to solve it? You can use a separate form limit x tend to a fx upon limit x tend to a gx. So this is the operation of the in algebra of the limit. Suppose at the separation form, then you separate here, segregate it. When it is the product form, then segregate it. When it is the quotient form, a division form, then you segregate it in this way. After that, we will discuss here. Then we will discuss here some identity here. First identity here. This portion is having completed. Second, suppose the limit using any rational function. So how to possible to get limit x tend to a, and this is the rational for x exponent n minus a exponent n upon x minus a in this form. Suppose question in this form, what is the result of this? That you can directly write there the n a exponent n minus 1. You will write here x exponent n minus a exponent n upon x minus a. You can write here n a exponent n minus 1. Second identity here, suppose here write limit x tend to a at x exponent n, then you can write here a exponent n. So in this way you can using the identity here. Next here, in relation between the trigonometry here, what is the relation between this? Suppose limit x tend to 0 here, the difference here a here integer 0, so sin x upon x, in the sin theta the value of this, means you can write a limit, otherwise you can write limit x tend to theta tend to, suppose you have theta tend to 0, and is sin theta upon theta result equal to 1. Second, next condition, fourth condition here, a limit x tend to 0 1 minus cos x. Suppose here x, then you write x. Suppose here theta, then you write here theta. So both conditions are same. Here you write here theta equal theta tend to 0. There is similar thing here theta. Theta plus here sin theta. Don't write here x. The similar here upon x. The result will be here 0. Suppose in this condition trigonometry is sin theta upon theta, the result is 1. For 1 minus cos theta upon theta equal to result is 0. So you will note down this identity here. Yes, so next discuss the exercise. Exercise 13.1 from NCERT book. Question number first here. To evaluate the following limits. First question here given. The limit x tend to 3 and x plus 3. So this is the very simple here. You have value of the x here 3. You will put the value of x equal 3. Then you get the answer. Then you second question. Then you will put here. Second step here you will x plus will putting the value of this. Then 3 plus 3 result here comes 6. This is your answer. When you put directly value of this x plus you are putting the value here 3. The 3 plus 3 here 6. Similarly, second question here, limit x tend to here pi is the irrational number x minus 22 by pi, 22 by 7. Then you will put x plus you will putting the value of pi minus 22 by 7. So don't replace of the pi here. This is your final answer. Don't replace of the pi here. So suppose again you putting the value of the pi here, then result will be 0. But no, don't replace of the pi here. You will same result will be here. Only replace x plus pi. Don't replace of the pi equal to 22 by 7. Then you cutting them. This is your final answer. Next question here, third question, limit r tend to 1 and pi r square. Since the pi is the same here, and value of the r is 1 square. The result is pi. This is your final answer. 1 square is 1. Then result is same. The next question here, fourth. Yes, student. Next question is question number 6. This is a different type of the question here. Yes, question here given ki limit ki x tend to 0 are here given ki x plus 1 whole power 5 minus 1 upon x. In this question, suppose you are putting the directly limit here, the result will come upon what result will become here ki 0 plus 1 is whole power minus 1 upon 0. Or when you divide by any number, divided by the 0 any number, the result will come the infinite. But you are using the limit here, a result come infinite. This is not possible. This condition is not correct, because you are using the limit. You are using the limit 0. What value of this function at 0? At 0. How it this is not possible. Ki value of the function at x equal to 0 is infinite. This is not possible. So then it means this is the incorrect answer. This one is the incorrect answer, because the value of this function at x equal to 0 is infinite. This is not possible. It means this is the wrong answer. It means then you will be change the condition here. So you will change the, suppose you are using the limit here in the identity here, the limit x tend to a x exponent n minus a exponent n upon x minus a. What value of this? This value over here, here value is a and a x n minus 1, or here value is the n and a exponent n minus a. You can suppose you are convert this function in this form, then you get the value of this in this form. So first of all, we will be changing something here. What change here? Suppose you are putting x plus 1 equal to h. In this place you are putting, suppose x plus 1 equal h. So then here x exponent 5 minus 1. But what value of the x here? Then you can write here value of the x here h minus 1. So in this place you will write here x place you will putting here h minus 1, and x plus 1 in this place you will changing value of the x h. So this is the this condition is change of the value of the function, but limit also will be changed here. When function is changed, the limit also change here. So now change the limit. Then you will write here change the limit. When function is changed, the limit also change. That means x plus 1 at x equal to 0, then value of the function is 0 plus 1 equal to h. You will putting the value at x equal to 0, means 0 plus 1 equal to h. So what value of the h equal? 1. Value of the h equal to here 1. And the limit is change here h x tend to 0, you will write here h tend to 1. Then now first of all you can write here limit x tend to 0, x plus 1 is 5 minus 1 upon x. You will changing here the limit h tend to 1, because this function is changing x to h. The x tend to 1 because value of the h equal to 1, and x plus 1 value are putting here h exponent 5 minus 1 upon, or what value of the x here? Value of the x here h minus 1. So suppose you will write here 1 exponent 5, the result is 1. So you can write here x 1 exponent 5. So this question is converted in this form, already converted here. So you will using the identity of the now the limit x tend to a x exponent n minus a exponent n upon x minus a. This will be converted here n x a exponent n minus 1. According this way, you can write here. So what is the n place here? N place here 5. N place here 5. A place here 1 and 5 minus 1 upon h place not upon the directly value. Then you can write here 5 into 1 is equal to 5. This is your answer. Or in this condition your answer comes the infinite. Suppose you are directly put the limit here, the result your come is the infinite. But this is the wrong answer. Your exact answer is 5. When limit x tend to 0, and in this function you are something changing in the function, so then student remember these things. When you changing in the function, something changes in the function, then change limit also. Suppose you are change only the function and you will be not change the limit, to your answer will come in the wrong. So when you changing the function, when any value function is changed here, x plus 1, anything you are given, then you also change in the limit also. Then you will change limit, change all the limit. What is the condition of the limit? Then you change and make the identity here, then you get the answer. So this is the 5 1 a place here 1 and n place here 5. To 5 minus 5 into 1 is 5. So in this way you can find the solution. That's the next question here. The similar question here, question number 7. Question number 7 here ki limit x tend to 2, or here given condition कि 3x square minus x minus 10, here x square minus 4. Suppose you are directly putting the here limit here, same thing condition question number 6. Suppose you are putting directly condition x exponent, the result what result come here कि 3 denominator will come the 4 minus 4 equal to 0, the result will come in the infinite. Suppose denominator will be here come 0, numerator to 4 minus 2 or minus 10. The result will always come here 0, because denominator portion is your 0. When you divide by the 0 any number, the result will come the infinite. That means this answer is the wrong. This condition is the wrong. You will never put the directly here the limit. Don't put directly here the limit here. You will changing something according to this identity here. So yes, first of all you will factorize of these questions. You will factorize of this question, then you will be solve it. So now you will write limit x tend to 2, then here 3x square minus x, what value here? You factorize 3x square minus x minus 10. So first we do the factor of this. So then 10 3 is 30, You will factor 10 is 30. Do the factor of 30 is 1. The 6 5 is 30. Then this is 6 5 is 30. So minus 6x plus 5x minus 10. So then you can write here, taking your 3x common. What result come here? Taking your 3x common. What is left here? X here. So 3 to just 6. Same thing here. Taking 5 common here. X minus 2. Here x minus 2 or here x minus 2. Again take x minus 2 or here 3x plus 5. The factor of this portion, this quadratic equation is this. You can write here x minus 2 and 3x plus 5. Or similarly here you can factorize of this x square minus 4. You can write here x square minus 2 square. Again x plus 2 and x minus 2. Here x minus 2 and x plus 2. After that this portion will be cancelled here. What is limit x tend to 2, and here left 3x plus 5 upon x plus 2. But this work also is fair work. This is not rough work. This is also in fair work. After that you are putting the limit, using the limit here, and then you get the answer. So what is the limit? 3 into 2 plus 5 and 2 plus 2. So what result come here? 3 to just 6 plus 5 11 and upon 4. So this is your final answer. And when you putting the direct limit here, then you will get answer is wrong answer, infinite. Then you will get the wrong answer is the infinite. This is a wrong answer. So after that you will solve something. This is the quadratic equation. You solve this quadratic equation in this way. This is the quadratic equation, solve according this way. Are putting the factor of this, then those factors are the common, then you cancel. After those factors remain here, then you write here and using the limit, and you find the value of here. Then according this way you can solve the questions. Every question you will solve in this way.